Hello, my name is David Klebanov. I'm a leader in Cisco Technical Marketing Organization. Today we're going to talk about an overlay management protocol, the OMP. It is Cisco SD-WAN control plane protocol that really powers the entire solution. Today we have Zain, a technical marketing engineer. Hi, Zain.
Hi, David. Thanks for having me.
Good to have you here. And we have Kural, a technical marketing engineer.
Thanks, David. Glad to be here.
Great. Our presenter today is Jigar, a senior software engineer in Cisco SD-WAN development organization. So Jigar, take it away.
Okay, thank you. Thanks all. Hi folks. So today I'll go over the overlay management protocol, that's the OMP. As David said, that's the core crux or the one which powers our Cisco SD-WAN solution. So without wasting further in time, let's go directly. So where does OMP or the overlay management protocol come into the picture in the SD-WAN solution? So it comes into the picture between a vEdge and a vSmart and between vSmarts themselves. How does OMP come up, or what are the endpoints for an OMP session to come up? So as we know, vSmart and a vEdge, the control connection between a vSmart and a vEdge comes up at the very first instance. So this is already a secure control connection channel which is based on a DTLS or a TLS connection. These are nothing but standards based protocols. So you have the control connection up until now between a vSmart and a vEdge, and control connection up between the vSmarts themselves. OMP runs inside this secure control connection. So OMP is already secure by the very fact that it is running inside the control channel itself. So between a vEdge and a vSmart and between the vSmarts, this is the OMP protocol running. Now, what is the endpoint for an OMP? It's nothing but a system IP. Now, what is a system IP? You can consider it a system IP to be a unique identifier for a particular entity in the SD-WAN solution. So be it a vEdge, be it a vSmart, be it a vManage or a vBond, each and every device in the SD-WAN solution is uniquely identified by its system IP. So for OMP, the endpoints are nothing but system IP. So a vEdge having system IP X with a vSmart having system IP Y will have OMP connection between them. Similarly, vSmart having system IP Y with a vSmart having system IP Z will have an OMP connection between them. So that's all you need for the OMP connection to come up. The endpoints as system IPs lying under the secure control connection.
So Jigar, I have a question. So you mentioned system IP. For those who are not familiar with the Cisco SD-WAN terminology, is there something familiar to them, like something that is similar to system IP in a non-SD-WAN world?
Yes, exactly, David. So a system IP in an SD-WAN world would map to what we call a BGP's router ID in a standards-based world. BGP, as we all might know, is a standard routing protocol widely famous. So a router ID in a BGP maps to a system IP in the SD-WAN world. Router ID, BGP, a system IP in the SD-WAN world. Thanks, David. So yes, that's what the brief overview was to get started with where OMP runs.
Yeah, another quick question is, when you talk about site ID, because you mentioned that, what if I have a site that's physically located with another vEdge, for example? Will their site ID or system IP be the same?
Yes, that's a good question. So if two vEdges, say vEdge 1 and vEdge 2, are physically located in a same site, they both will have the same site ID. So say the site ID is 1, for example, both of them will have the same site ID, that's site ID 1, but both will have a unique system IP, say X and Y. So that's how the hierarchy goes, like, hey, you have a site where you can have multiple edges. Each edge is uniquely identified by its system IP then.
So the routes will be advertised to the vSmarts based on a site ID, correct?
The routes would be advertised based on a system IP, not a site ID per se. So Zain, does that answer your question?
Thank you.
Okay, sure. So moving on. So on the basic introduction part, OMP is unique to the SD-WAN solution. Unique meaning there's no interop required with any non-Cisco SD-WAN device. So a device running, say, OMP on a Cisco edge, and say there is some other third-party device. So OMP will not be functioning between these two. OMP is unique to the SD-WAN solution itself. OMP runs on the WAN side. Let me just go over an overview of what is a WAN side. So as you might be familiar, there are VPNs which are involved in the SD-WAN solution. VPN is nothing but you can consider it as a separate routing table of its sort. VPNs are isolated from each other, like a VPN 1 versus a VPN 2 won't be sharing the routes by themselves. VPN 1 would be a separate routing table, VPN 2 would be a separate routing table. So in the SD-WAN world, OMP is part of the transport VPN per se, and the LAN side, that is the non-VPN zeros, would still be running your standard protocols like the OSPF, the BGP, static routes, connected routes, and stuff like that. So here you'll be having, say, your service side where, say, a particular PC or a laptop is connected to the service side. That's why we call it the service side, because the edge device, the WAN edge device, is servicing something on the LAN side, and on the WAN side, the edge device would act as a client by himself. So that's where the LAN and WAN terminologies come in handy. Like I said, it is similar to BGP. To begin with, we already know that a system IP maps to a router ID. I'll go over further with the similarities as and when we encounter them. OMP carries 4 main attributes. That's the routes. Routes meaning what are the LAN side routes being advertised, because the entire basis of the SD-WAN solution is to connect offices, is to connect sites, connect branches, and stuff like that. So how do you connect sites? That's by advertising certain routes, and that is taken care by the overlay management protocol. How do you advertise T-logs? A T-log, you all might be familiar, is a combination of system IP plus color plus the NCAP. System IP, we all know, uniquely identifies a device per se. A color uniquely identifies a WAN interface, to be precise. So a WAN interface on a vEdge having color X and color Y. So with the system IP, you will be able to identify, hey, this is my edge device 1, be it a vEdge or a cEdge. And then using the colors, you will be able to identify, hey, this is my actual WAN interface X or Y. So as you know, by this per se, there cannot be 2 same colors lying on a particular edge device. And then comes the NCAP type. So today we support the encapsulation of IPsec and the GRE protocols. These are, again, the IPsec and GRE are not the standards based, that is tweaked a bit for our own SD-WAN solution. So that's what defines a T-log. I'll go over each of them in detail, but this is just to give an overview that, hey, routes, T-logs are the main entities getting carried. Then we have something known as services. Services, in a brief, would be like, hey, vEdge1 has a VPN1. vEdge2 has been defined a VPN2. So these are nothing but services that get carried. So these help in isolation of VPNs, like, hey, how do I make sure traffic from vEdge1, VPN1 is not getting advertised to vEdge2, VPN2, because VPN by itself is a service for an OMP. So OMP knows that, hey, my vEdge1 has VPN1, my vEdge2 has VPN2. So I should not, exchange routes between these entities. I should make sure VPN1's route are advertised only to the vEdges or edges which have VPN1 defined themselves. This is one example of services. There are many other services that we carry, like a firewall as a service and stuff like that. Then we have something known as policies, which are driven by OMP. So policies are, these are the centralized policies that we are talking about. Centralized policies meaning policies which are pushed from a vSmart. So a change which you would want to be a network-wide change. Those are the policy-driven changes. that OMP is significant to carry. So these are the main 4 attributes. We'll go into each one of them in detail, and I'll show you where and how it matters. Like I said, OMP runs between a vEdge and a vSmart, and between vSmarts. So as you can see, there's no vManage in the picture, or there's no vBond in the picture when it comes to OMP. Any questions out here? Okay, sure. And we already discussed OMP comes up on top of a secure control connection.
So is an OMP, is it TCP based, UDP based? Like what's the underlying sort of the guts of the transport of the OMP itself?
So for OMP, we are running on top of DTLS or a TLS by itself. So DTLS is a UDP based where you have certain mechanism to handle the acknowledgement, because UDP by itself does not handle. And TLS is by itself running on over TCP. So both worlds are equivalent. So if your OMP connection has come on top of a DTLS connection, you are riding on top of a UDP connection. If your OMP connection has come up on top of a control connection based on TLS, you're riding on top of a TCP connection.
So Jigar, why can't OMP be considered an industry standard routing protocol?
So OMP, for now, it's not an industry standard routing protocol because, like I said, it is unique to the SD. That's what makes the SD-WAN so easy to come up with. That's because OMP was designed in a certain manner that, hey, it can operate only between the certain type of edge devices. Like, for example, today, Cisco WAN Edge has the software capabilities to handle, hey, OMP interacts with this entity in this manner. For say any other entity XYZ does not know the software crux of how does an OMP work. It's not an RFC defined where anybody can take it, code it, and have it in place in their software. So that's what makes it unique to the SD-WAN solution.
Jigar, I have a question. Yes. If OMP is proprietary, how do you interoperate with other non-SD-WAN devices to exchange routes and other things?
Yes, exactly. So like we said, we still support the OSPF, BGP, static connected routes and stuff like that. So say this is the SD-WAN device. Again, VPN 0 and the service VPNs here. And this is, say, a non-SD-WAN device. You can still have, for example, a BGP running between these two. You can still run on VPN 0 itself, but then you should not expect an overlay or a secure control connection or a BFD channel to come up on these things. Again, BFD and stuff like that, we'll move on, dig further when we talk about TLOCs and routes and stuff. But yeah, to interop, you have the standards protocol supported as itself.
Okay, so the other routes can be redistributed into the SD-WAN environment.
Correct, exactly. So the route redistribution part and stuff like that, OMP will take care of it. Sure. Okay, so OMP is automatically enabled at bring up. So OMP has like a basic, what we call it a shut or a no shut state. That's an automatic enablement. So when you plug into the box, the OMP process is running for you. And like I said, the endpoints are system IP. So a diagrammatic representation would be, you have what you call a transport side and a service side. This is a vEdge 1 having system IP 1.1.1.1, vEdge 2 having certain system IP, each having, for this example, a unique site ID, and there's a vSmart having its own system IP.
When you say endpoints, they are SD-WAN components, right? Not the actual endpoints pieces like that.
Yes, so these are the OMP and endpoints are system IPs. So for the OMP session to come up, the endpoints would be system IPs by themselves. So when you have the control connection in place, like imagine this is the control connection, OMP would come up between this system IP and this system IP. On the other side, OMP would come up between this system IP and this system IP. So for all OMP needs to know is, hey, what is the system IP of my far-end device? If he knows that, and if the entity is the supported entity, like a vSmart vEdge combination or the vSmart combination, then OMP would come up.
One quick question is, can you go through the workflow? If I am a vEdge, for example, do I first advertise my TLOC in one advertisement? And then in my second, now I start advertising my server side?
Sure. So advertising the TLOCs routes, I'll so those are the next up slides. Let me discuss them in detail in that manner. Any questions on these, on the basic introduction part? Then we'll dig deeper into all the 4 components that we mentioned.
Now the transport, you're depicting here a transport and a service. Is that what you described in the previous slide as VPN 0 and a service-side VPN?
Exactly, yes. So this is what we call a WAN side or a VPN 0 side or a transport side. We'll use, like SD-WAN uses these terms interchangeably, and a service side would be a service side by itself, or a LAN side, or a non-VPN 0 side. So that's how you differentiate. Exactly, David. Okay. Any further questions on these? Okay.